With everything we love about ACLs and all the different purposes we use them for, whether it's denying traffic, permitting traffic, identifying traffic, we use them on physical interfaces, we've used them on logical interfaces, it is hard to believe that there's actually a spot in your network where ACLs are by themselves ineffective. And I'm going to show it to you right now. It's got to be something really complicated, right? Wrong. It doesn't have to be complicated at all. We've got three hosts, all obviously from the same subnet. All have the same mask. I'm not pulling any tricks on you here. Hosts 1, 2, and 3 from 10.1.1 to 10.1.1.3, all in VLAN 10. And so what's the problem? Well, with an ACL, this is the issue. An ACL can filter traffic traveling between VLANs, but not traffic from one host to another in the same VLAN. And the reason is the application of ACLs on a multi-layer switch. And I know I'm showing you the classic layer 2 switch diagram there, but just to get you used to it, not every network map you ever look at that has a layer 3 switch is going to have the official layer 3 symbol. So you might just look at a switch like this on a map, and then when you get on it, you say, okay, it's a multi-layer switch. So here's just a few nuts and bolts about why and what's going on here. Now, the CAM table, we know all about that. CAM table, MAC address table, physical address table, whatever you want to call it, that contains all the dynamically and statically learned MAC addresses. But it is the ternary content addressable memory table, the TCAM table, that cuts down on the number of lookups required to compare a packet against an ACL. Now you hear that and you go, Chris, that's a wonderful random fact. What does that have to do with my life? Well, here's what it has to do with ACLs. This packet filtering via switch hardware, it speeds up the overall process, which are all for, but it also limits ACL capability to enter VLAN traffic. So if we're filtering between hosts in the same VLAN on a multi-layer switch, we've got to use something called a VLAN access list, a VACL. And you're already thinking, oh, another kind of access list. Are you kidding me? Well, not really, because there will be an ACL in the config. We're actually going to start our configuration with an ACL. It's really just applied a different way. That's all there is to it. You're going to use a couple commands that you won't use in any other situation, but the access list itself is going to look just like an ACL that you would write anywhere else. Now, here are the requirements for this lab. Nothing fancy. What we're going to do is set it up, have some fun. None of the three hosts on that segment, 10.1.1.1, 2, or 3, are allowed to communicate with any of the others. Nor should they be allowed to communicate with any host put on that overall segment in the future, 10.1.1.0/24. Got to keep that in mind when we're writing our ACL. Now, if other hosts are placed on that subnet and in that VLAN, the new hosts should be able to ping each other, but not the current three hosts. That sounds like something. Well, let's go ahead and dive in and get started. First, we're going to write our ACL. And I'm going to write an extended ACL. And I'm going to give it the name block 123. Now, I'm going to permit IP. Now, what do I need for the source address? Because if we go back to the requirements, it's saying none of these three hosts should be allowed to communicate with any of the others, but if we have hosts from that same subnet put on in the future, they should be able to talk to each other. So the source of this should only match 10.1.1.1, 2, and 3 according to those requirements. We want them to match only those three hosts. So the first part of this, easy enough. What are the wildcard bits here? I know you know this. I'm just giving you a little extra time no matter what. You pause the video if you need a little more time. To match only the host addresses that end in 1, 2, and 3, what you're putting here is 0, 0, 0, 3. So something a little different there. We need to get away from always doing 255 here. Now, what about this destination? Because again, if we go back to the requirements are that none of the three hosts that are already there should be allowed to communicate with each other or any host that's ever put on 10.1.1.0/24. So we're not going to go with the same wildcard mask here. We're saying the destination is anywhere on the 10.1.1.0/24 network, and we know what that one is. 10.1.1.0.0.0.255. And that's it. That's it for the ACL, that is. Now, you're probably looking at that, especially if your first time around with this, and you're thinking, well, first off, for something that isn't an ACL, that sure looks like an ACL. You know, VLAN access list sounds so different, but you're always going to write an ACL as part of the VACL. And more likely, you might be thinking, why are we permitting the very traffic that we're talking about denying? Why does that ACL have a permit statement? If I'm actually denying traffic. Well, I'm not doing the denial yet. The ACL is not doing the denying in this particular case. With the VACL, we're not permitting or denying traffic with the ACL. We're identifying traffic. We're identifying traffic upon which action is to be taken. And I'm put it that way because we're actually going to use the word action in the config as we start writing the VACL with the VLAN access map. And we're going to go ahead and go forward with that right now. Or not. And the command here is VLAN access map. And it's going to ask you for a name. I'm going to call it block 123 as well. Now, there is no requirement for your ACL and the associated VACL to have the same name. You might not want to do it that way. I like to do it that way in this case. So I'm going to put 123 there. And I have the option to put in a sequence number. It's just cutting off the word entry there, that's all. So I can put a sequence number in, but I'm not going to do that because I want to show you what the defaults are. It's important stuff to know. So I'm just going to go with VLAN access map, block 123, and now I'm in VLAN access map configuration mode. Now what I want to do, what you're almost always going to see in an access map clause is a match and an action. If this value is matched, take this action. Not every time, but most of the time. So let's look at some of the things we can match against. Well, IP or MAC based, we're going to stick with IP. And address. And that's it. So when you see match IP address, that might throw you. It's like, well, I'm not putting in an actual address. No, you're not. You're putting in the ACL. This is where the ACL is going to be called. So I'm going to put block 123. That's what I called the ACL. And now I need to take an action against traffic that matches that. And here are your options. You know, you can forward it or you can drop it. And we're going to drop that traffic. And you see the logic now of making our ACL a permit because we're using it to identify traffic. And let me do a show VLAN access map here. And a couple things to show you here. First off, there's the default sequence number of 10. That is the same as numbered ACLs. And the way I like to remember it, it starts with 10 and increments by 10. Every clause I put after this, it's going to go 20, 30, 40, etc. And if I need to put a clause in front of this, then I would give it a sequence number of less than 10. So here's your match clause, IP address block 123. So that's why we had the permit in the ACL. This clause is saying if it matches the ACL block 123, then I want you to drop it. But what about the other traffic? We need to do a little something about traffic that doesn't match that because there's going to be a whole lot of it. And we might want to test out what happens if new hosts come on the scene later on. We'll do that on the very next video.